What if you could rewire your brain like a computer? What if intelligence, memory, and focus were things you could upgrade at will? It sounds like science fiction, a concept straight out of a futuristic novel where humans enhance their cognitive abilities with a few simple hacks. But what if this wasn't just fantasy? What if, right now, science is uncovering ways for you to reprogram your brain, boost your mental performance, and unlock abilities you never thought possible? The idea of hacking the brain isn't new, but it's becoming more of a reality than ever before. Advances in neuroscience and technology are revealing that the brain isn't a static organ. It can change, adapt, and even rewire itself based on external influences and deliberate interventions. This is the foundation of neurohacking, a field dedicated to optimizing brain function using scientifically proven techniques. Whether through diet, meditation, brain training exercises, or even high-tech devices, neurohacking explores the methods that can enhance memory, increase intelligence, and improve focus. Brain hacking isn't just a trend, it's a practice already being used by some of the world's most elite performers. Silicon Valley executives, Wall Street traders, military strategists, and even Olympic athletes are constantly searching for ways to gain a cognitive edge. CEOs and entrepreneurs invest in biohacking methods to sharpen decision-making skills. The military is researching ways to enhance focus and reaction time in soldiers. Even students and professionals are experimenting with smart drugs and nootropics to improve learning and retention. The race to optimize the human brain is well underway, and those who understand how to harness this knowledge may gain an unparalleled advantage. But here's the big question. How much of this is real, and how much is hype? Can you actually manipulate your brain's neural pathways, or is neurohacking just another overpromised trend? The science behind brain hacking is both fascinating and controversial, with real studies showing measurable changes in brain function. Some techniques have been proven to rewire the brain for better performance, while others exist in a gray area of speculation and ethical debate. By the end of this video, you'll discover the shocking truth behind neurohacking. You'll learn how cutting-edge science is unlocking the brain's hidden potential, which methods actually work, and whether it's possible to transform yourself into a smarter, faster, more efficient version of yourself. The secrets to reprogramming your mind aren't locked away in a laboratory, they're available for anyone willing to explore them. This journey into the world of neurohacking will separate fact from fiction, uncover the techniques that scientists and top performers are already using, and explore the future of human intelligence. If you've ever wanted to take control of your mind, enhance your mental capacity, and push your cognitive abilities beyond their limits, you won't want to miss what comes next. The science of neurohacking, how the brain works. The human brain is often compared to a supercomputer, but in reality, it's far more complex than any machine ever created. Unlike a traditional computer, which has fixed circuits, the brain has the ability to change its structure and function based on experiences, thoughts, and behaviors. This phenomenon is known as neuroplasticity, a groundbreaking discovery that has revolutionized neuroscience and cognitive science. For decades, scientists believed that brain development stopped after childhood, that the neural pathways we were born with determined our intelligence, memory, and cognitive potential for life. But modern research has shattered that myth. The brain is dynamic, constantly rewiring itself in response to new information, habits, and even emotions. This means that intelligence is not fixed, and neither is memory or problem-solving ability. With the right techniques, the brain can be trained to form new neural connections, strengthen existing ones, and even recover lost functions after injury. Neuroplasticity explains why people who suffer strokes can sometimes regain lost abilities through rehabilitation. It's also why musicians and athletes who train extensively develop specific brain regions that are more active than those of non-practitioners. Every time you learn something new, whether it's a language, a skill, or even a mental habit, your brain is physically changing. New neural pathways are created, synapses strengthen, and gray matter density increases in the areas associated with the learned task. This means that hacking your brain isn't just about psychology, it's about biology. By understanding how neuroplasticity works, you can deliberately shape your brain's wiring to enhance memory, improve focus, and even boost intelligence. The key is repetition and engagement. The more you stimulate certain neural pathways, the stronger they become. Just like muscles grow with resistance training, neurons strengthen through repeated use. Case study: London taxi drivers and brain structure changes. One of the most compelling pieces of evidence for neuroplasticity comes from a famous study on London taxi drivers. Unlike regular drivers, London's black cab drivers must pass a rigorous test known as the Knowledge, which requires them to memorize over 25,000 streets, landmarks, and the fastest routes through one of the most complex road networks in the world. The test takes years to prepare for, and only a small percentage of candidates pass. Neuroscientists wanted to understand how this extreme memorization affected the brain, so they conducted brain scans on London cab drivers and compared them to ordinary people. The results were shocking. The hippocampus, the part of the brain responsible for spatial navigation and memory, was significantly larger in taxi drivers than in the general population. The more years a driver had spent on the job, the more developed this region of the brain became. This study proved that mental training physically reshapes the brain. The growth of the hippocampus wasn't a genetic trait, it was the direct result of years of intense cognitive exercise. Even more interesting, when retired taxi drivers were studied, their hippocampus started to shrink again, showing that neuroplasticity works in both directions. Use it, and your brain grows stronger. Ignore it, and certain cognitive abilities decline. This has enormous implications for anyone looking to enhance their brain function. If memorizing complex maps can increase brain size, what else could be possible? Could training specific mental skills improve problem-solving abilities, increase creativity, or even raise IQ? Science suggests the answer is yes, and it all comes down to the chemicals that drive brain activity. The role of neurotransmitters. If neuroplasticity is the hardware that allows brain hacking, neurotransmitters are the software. These chemical messengers dictate how the brain functions, affecting everything from memory and focus to mood and motivation. Understanding them is key to optimizing brain performance. Dopamine is often called the motivation molecule because it plays a crucial role in reward-seeking behavior. Every time you experience a sense of accomplishment, whether from completing a task or achieving a goal, dopamine is released. This not only makes you feel good but also reinforces the behavior, making you more likely to repeat it. This is why people who set and achieve small goals consistently tend to be more productive. They are effectively hacking their brain's reward system. Serotonin is the neurotransmitter linked to mood and emotional stability. Low serotonin levels are associated with depression and anxiety, while higher levels contribute to a sense of well-being. Practices such as meditation, exposure to sunlight, and exercise have been shown to boost serotonin levels naturally, making them powerful tools for brain optimization. Acetylcholine is the key neurotransmitter for learning and memory. It plays a critical role in focus, helping neurons communicate effectively. Studies have shown that increasing acetylcholine levels can lead to enhanced cognitive function, improved recall, and faster information processing. This is why nootropic supplements like alpha-GPC, which increase acetylcholine levels, are popular among those looking to enhance their brain power. GABA, or gamma-aminobutyric acid, is the brain's primary inhibitory neurotransmitter. While dopamine and acetylcholine excite neurons, GABA calms them down, preventing overstimulation. It helps regulate stress and allows the brain to function in a balanced state. People with low GABA levels often experience anxiety and mental fatigue, which is why relaxation techniques like deep breathing and mindfulness are essential for maintaining optimal brain function. Each of these neurotransmitters plays a unique role in brain performance, and they interact in complex ways. Too much dopamine can lead to impulsive behavior, while too little can result in lack of motivation. High acetylcholine levels can enhance memory, but an imbalance can cause mental burnout. Effective neurohacking requires an understanding of these chemicals and how to balance them for maximum cognitive performance. The shocking truth: the brain physically changes based on what we do, think, and feel. The idea that the brain is constantly rewiring itself isn't just an abstract concept, it's a scientific fact. Every thought you have, every action you take, and every experience you go through leaves a physical imprint on your neural pathways. This means that your habits, both good and bad, are shaping your brain in real time. If you repeatedly engage in negative thinking, your brain strengthens those neural circuits, making pessimism your default state. On the other hand, if you train yourself to practice gratitude or positive visualization, those neural pathways become dominant. This is why affirmations, meditation, and cognitive behavioral therapy can produce measurable changes in brain activity. Studies using fMRI scans have shown that people who practice mindfulness meditation for just 8 weeks experience increased gray matter density in areas related to emotional regulation and memory. Similarly, research on musicians has found that long-term practice leads to structural changes in the auditory and motor cortices, enhancing their ability to process sound and execute complex movements. Perhaps even more shocking, scientists have found that mental imagery alone can alter the brain. In one study, two groups of people were asked to perform a finger exercise. One group physically practiced the movement, while the others simply visualized themselves doing it. At the end of the study, both groups showed similar changes in the motor cortex, proving that mental rehearsal alone can reshape neural circuits. This has massive implications for brain hacking. It suggests that visualization techniques, mental exercises, and even mindset shifts aren't just psychological tricks, they are physically rewiring the brain. The same way a London taxi driver's hippocampus grew through navigation training, anyone can alter their brain structure through targeted cognitive practices. The bottom line is clear: the brain is an adaptable organ that responds to the demands placed on it. Whether you want to improve memory, enhance creativity, or increase intelligence, the science of neuroplasticity and neurotransmitters shows that it's possible. The only question is, how far can you push it? If the brain is capable of such radical transformation, what else can be unlocked with the right techniques? The world of neurohacking is just beginning to uncover the answers, and as we explore the methods and tools available, one thing is certain: human potential is far greater than we've ever imagined. Can you really hack your brain? What is brain hacking? The idea of brain hacking sounds like something out of a science fiction movie, but it's a real and growing field that blends psychology, neuroscience, and cutting-edge technology to enhance cognitive abilities. Unlike traditional methods of learning or improving memory, brain hacking is about leveraging scientific discoveries to make lasting changes in how the brain functions. This can include anything from mental training exercises and meditation to using nootropic supplements, brainwave stimulation, and even artificial intelligence-assisted cognitive enhancement. The term hacking usually refers to manipulating a system to improve or modify its performance. In the context of the brain, hacking means tapping into the brain's neuroplasticity, the ability to rewire and adapt, to optimize memory, learning, creativity, and focus. Some methods rely on natural processes, like practicing mindfulness or engaging in deep learning strategies, while others use biohacking techniques such as transcranial magnetic stimulation, smart drugs, and neural implants. Elite performers, including CEOs, athletes, and military personnel, have long sought ways to push their cognitive abilities beyond natural limits. Silicon Valley is at the forefront of this movement, with executives experimenting with everything from microdosing psychedelics to wearing neurostimulation headsets to enhance problem-solving and decision-making. Some people rely on simple but effective strategies like fasting for mental clarity, while others explore more experimental approaches like using artificial intelligence to track brain activity and adjust cognitive states in real time. But how far can brain hacking really go? Can intelligence, memory, and problem-solving ability be upgraded like a computer program? The answer, according to modern neuroscience, is more promising than most people realize. Research shows that intelligence isn't a fixed trait, and the brain is more adaptable than once believed. The myth of intelligence limit. For years, the common belief was that intelligence is mostly determined by genetics. The idea that IQ is set at birth and remains unchanged throughout life was widely accepted. However, scientific breakthroughs in neuroplasticity and cognitive science have proven that this is a myth. Intelligence is not static, and various methods can enhance cognitive function, improve problem-solving skills, and even raise IQ scores over time. One of the most compelling studies that debunked the fixed intelligence myth was conducted by Swiss neuroscientist Susanne Yeji. Her research focused on working memory, which plays a crucial role in intelligence. She and her team discovered that with the right mental training exercises, people could significantly improve their cognitive abilities. The implications of this study were groundbreaking. It suggested that intelligence could be strengthened like a muscle, given the right kind of training. The brain is constantly forming new connections between neurons, and this adaptability means that even fundamental aspects of intelligence, such as processing speed, memory retention, and analytical thinking, can be improved. People who engage in lifelong learning, problem-solving challenges, and brain training exercises consistently show cognitive growth. This means intelligence is not an unchangeable trait but something that can be cultivated through the right mental exercises. Education systems and workplace training programs have started to take advantage of this knowledge, incorporating cognitive training techniques designed to enhance learning efficiency. But the potential for hacking intelligence doesn't stop there. A more structured approach to cognitive enhancement, known as the dual N-back test, has shown even more impressive results in brain optimization. Case study: the dual N-back test and how it boosted working memory. One of the most well-known brain hacking tools to emerge in recent years is the dual N-back test, a scientifically proven exercise designed to strengthen working memory. Unlike traditional brain games that claim to boost intelligence but lack scientific validation, the dual N-back test has been extensively studied and shown to produce measurable improvements in cognitive function. The test works by challenging participants to track visual and auditory patterns over a series of trials, forcing them to hold and manipulate information in real time. As the difficulty increases, the brain is pushed to expand its working memory capacity, a key component of intelligence. In a landmark study, researchers found that people who practiced the dual N-back task for just 20 minutes a day over several weeks showed significant gains in working memory and fluid intelligence, the ability to reason and solve new problems. What makes this study so important is that fluid intelligence was long thought to be largely unchangeable after adolescence. But the results proved otherwise. The test showed that with the right kind of cognitive challenge, the brain could improve its ability to process and recall information, leading to higher problem-solving skills and faster learning. This has massive implications for anyone looking to enhance their mental capabilities, whether for academic performance, professional success, or personal growth. Some cognitive scientists believe that similar brain training exercises could be adapted to improve creativity, emotional intelligence, and even decision-making. While the dual N-back test focuses on memory and pattern recognition, future variations could target other cognitive functions, effectively creating customized brain training regimens tailored to an individual's needs. These findings have fueled a growing industry of brain enhancement tools, with companies developing apps and programs based on neuroscience-backed training methods. But this movement is not without controversy. The idea of artificially boosting intelligence through technology raises ethical questions, particularly as neurohacking moves beyond simple exercises and into more experimental territory. The controversial side of brain hacking. While brain hacking presents exciting possibilities, it also raises significant ethical and safety concerns. The idea of enhancing intelligence and cognitive abilities through artificial means challenges traditional views on natural human limitations. Some scientists argue that cognitive enhancement could create an unfair advantage, particularly in competitive fields like academia and business. If certain individuals have access to neurohacking technologies that improve memory, focus, and problem-solving speed, will this lead to a new form of inequality? The use of smart drugs, also known as nootropics, has been a growing trend among professionals, students, and even military personnel. Modafinil, a prescription drug originally developed to treat narcolepsy, has become popular among individuals seeking to boost wakefulness, concentration, and cognitive endurance. While studies have shown that it can enhance executive function, some researchers warn that prolonged use may have unintended consequences on the brain. The long-term effects of cognitive-enhancing drugs are still unknown, and the ethical debate surrounding their use is intensifying. In addition to pharmaceuticals, brain stimulation devices are entering the mainstream. Transcranial direct current stimulation, TDCS, involves applying a mild electrical current to specific areas of the brain to enhance cognitive performance. Some studies suggest that TDCS can improve memory, problem-solving skills, and even motor learning. However, concerns about the safety and long-term effects of brain stimulation remain largely unresolved. Scientists worry that frequent use could disrupt natural brain function, potentially leading to cognitive imbalances or unintended side effects. Perhaps the most controversial area of neurohacking involves brain-computer interfaces. Elon Musk's Neuralink project aims to develop a direct connection between the human brain and artificial intelligence, allowing people to upload and download information directly into their minds. While this technology is still in its early stages, it presents profound ethical dilemmas. If the human brain can be modified with implants to process information faster or access digital knowledge in real time, does this redefine what it means to be human? Could such enhancements be reserved for the wealthy, creating a cognitive divide between those who can afford brain augmentation and those who cannot? As technology advances, society will have to grapple with the implications of neurohacking. While many of these innovations hold promise for medical applications, such as treating neurodegenerative diseases like Alzheimer's, the potential for misuse cannot be ignored. Governments and regulatory bodies may eventually step in to set limits on cognitive enhancement, just as they have with performance-enhancing drugs in sports. Despite the ethical debates, one thing is certain: brain hacking is here to stay. The science of cognitive enhancement is advancing rapidly, and whether through natural training methods or cutting-edge technologies, people are already exploring ways to push the boundaries of human intelligence. The question is no longer whether we can hack our brains, but how far we are willing to go. Natural brain hacking technique, diet and brain power. The food you eat is more than just fuel for your body. It directly impacts your brain's ability to function at peak performance. The connection between diet and cognitive function is one of the most well-documented areas of neuroscience. Some foods enhance memory, boost mental clarity, and improve overall brain health, while others contribute to brain fog, sluggish thinking, and even long-term cognitive decline. One of the most important nutrients for brain function is omega-3 fatty acids. Found in fatty fish like salmon, sardines, and mackerel, as well as in walnuts and flax seeds, omega-3s play a crucial role in building and maintaining brain cells. Studies have shown that regular consumption of omega-3s is linked to improved memory, faster processing speeds, and even a reduced risk of neurodegenerative diseases like Alzheimer's. The reason omega-3s are so powerful is that they contribute to the integrity of brain cell membranes, keeping neurons flexible and capable of efficient communication. Turmeric is another brain-boosting superfood that has gained widespread attention in recent years. The active compound in turmeric, curcumin, has been found to cross the blood-brain barrier and act as a powerful anti-inflammatory and antioxidant. Research has shown that curcumin helps clear amyloid plaques in the brain, which are associated with cognitive decline. Additionally, turmeric has been linked to increased levels of brain-derived neurotrophic factor, BDNF, a protein that supports neuron growth and enhances learning and memory. Blueberries, often referred to as brainberries, are another potent cognitive enhancer. Packed with antioxidants, they protect the brain from oxidative stress and reduce the effects of aging. Studies have found that regular consumption of blueberries can delay brain aging by up to 2.5 years and improve communication between neurons. The anthocyanins in blueberries are particularly effective at enhancing memory and cognitive function. Dark chocolate, particularly varieties with a high cacao content, is also a natural brain booster. Cacao contains flavonoids that increase blood flow to the brain, enhancing focus and cognitive performance. The presence of small amounts of caffeine in dark chocolate further supports alertness and mental clarity. A brain-boosting diet isn't just about adding superfoods. It's also about eliminating the foods that slow cognitive function. Processed sugars and refined carbohydrates cause spikes and crashes in blood sugar levels, leading to brain fog and reduced mental energy. Artificial trans fats, often found in fast food and packaged snacks, have been linked to a higher risk of dementia and impaired cognitive function. Optimizing your diet is one of the most effective and sustainable ways to hack your brain naturally. By consistently fueling your mind with nutrient-rich foods, you can enhance focus, sharpen memory, and protect long-term brain health. Exercise and brain growth. Physical exercise isn't just good for your body. It's one of the most effective ways to stimulate brain growth and cognitive function. Scientists have discovered that exercise promotes the production of new neurons, a process known as neurogenesis. This discovery challenged the long-held belief that adults cannot grow new brain cells. In fact, research now confirms that exercise plays a key role in enhancing memory, learning ability, and overall cognitive performance. One of the most famous studies on the impact of exercise on the brain was conducted on mice. Researchers placed one group of mice in cages with running wheels and another group in cages without them. After several weeks, the brains of the exercising mice showed a dramatic increase in new neurons in the hippocampus, the area responsible for learning and memory. When the same experiment was conducted on humans using aerobic exercise, similar results were found. Regular physical activity increased hippocampal volume, improved cognitive flexibility, and enhanced problem-solving abilities. Exercise triggers the release of several brain-enhancing chemicals, including BDNF, which supports the survival and growth of neurons. It also boosts dopamine and serotonin levels, improving mood and reducing stress, both of which contribute to better cognitive function. Even a simple daily walk has been shown to increase blood flow to the brain and improve memory recall. Strength training, in addition to aerobic exercise, has also been linked to cognitive improvements. Lifting weights has been found to enhance executive function, which includes decision-making, problem-solving, and multitasking. The combination of cardio and strength training provides the best cognitive benefits, making exercise a powerful brain hacking tool. Meditation and neuroplasticity. Meditation has long been associated with mental clarity, but recent scientific studies prove that it physically changes the brain. Even just 10 minutes of meditation per day has been shown to increase gray matter density in regions linked to memory, learning, and emotional regulation. A groundbreaking study from Harvard found that people who practiced mindfulness meditation for 8 weeks had increased cortical thickness in the prefrontal cortex, the area responsible for executive function and attention control. At the same time, the amygdala, the part of the brain responsible for stress and fear, actually shrank. This suggests that meditation not only enhances cognition but also reduces anxiety and emotional reactivity. Meditation trains the brain to focus, filtering out distractions and improving concentration. Regular meditation practitioners show greater activity in the default mode network, DMN, the part of the brain responsible for introspection and problem solving. The benefits of meditation aren't just limited to mental clarity. It has been shown to enhance creativity, improve memory retention, and even slow down age-related cognitive decline. Studies have found that long-term meditators have brain structures that resemble those of much younger individuals, suggesting that meditation is a powerful tool for keeping the brain sharp over time. Sleep and memory optimization. One of the most overlooked but crucial brain hacking techniques is sleep. Sleep isn't just a passive state, it's an active process where the brain consolidates memories, removes toxins, and strengthens neural connections. During deep sleep, the brain goes through a process called synaptic pruning, where unnecessary connections are eliminated while important ones are reinforced. This process plays a vital role in learning and memory retention. Research has shown that people who get sufficient deep sleep perform significantly better on cognitive tasks than those who are sleep deprived. The glymphatic system, the brain's waste clearance system, is also most active during sleep. This system flushes out metabolic waste, including beta amyloid, a protein associated with Alzheimer's disease. poor sleep has been linked to an increased risk of neurodegenerative diseases, mood disorders, and impaired cognitive function. Power naps have also been shown to provide cognitive benefits. A short 20-minute nap can boost alertness, while a longer 90-minute nap allows the brain to complete a full sleep cycle, enhancing creativity and problem-solving skills. Cold showers and mental resilience. Cold showers and exposure to cold temperatures have surprising benefits for brain function. The Wim Hof method, which combines cold exposure with specific breathing techniques, has gained attention for its ability to enhance mental resilience, focus, and even immune function. Cold exposure triggers the release of norepinephrine, a neurotransmitter associated with increased alertness and mood regulation. This explains why people who take cold showers often report feeling more awake and energized. The shock of cold water also stimulates blood flow to the brain, improving oxygenation and cognitive function. Studies have found that cold exposure can increase the density of brown fat, a type of fat that helps regulate body temperature and metabolism. More importantly, cold exposure strengthens the nervous system, improving stress tolerance and reducing anxiety. Athletes and peak performers often use cold therapy to enhance recovery and mental toughness. By training the body to handle stress through cold exposure, the brain adapts by increasing focus, resilience, and overall cognitive endurance. Neurohacking doesn't require high-tech devices or experimental treatments. Many of the most effective brain optimization techniques are rooted in nature and daily habits. By fine-tuning diet, exercise, meditation, sleep, and resilience-building techniques like cold exposure, it's possible to enhance memory, focus, and mental clarity, naturally. These methods tap into the body's built-in mechanisms for cognitive enhancement, proving that the brain is capable of extraordinary growth and transformation when given the right conditions. Biohacking your brain with technology. Smart drugs and nootropics. The idea of using substances to enhance brain function has been around for centuries, but modern neuroscience has taken it to a whole new level. Smart drugs, or nootropics, are substances that claim to improve cognitive abilities, including memory, focus, creativity, and motivation. These compounds range from naturally occurring herbs and vitamins to pharmaceutical-grade drugs designed to enhance mental performance. But do they really work? One of the most widely discussed nootropics is modafinil, a prescription drug originally developed to treat narcolepsy. It has gained popularity among students, entrepreneurs, and professionals looking for a cognitive edge. Research has shown that modafinil enhances executive function, increases alertness, and improves focus, making it particularly useful for tasks that require sustained attention. Unlike caffeine, which can cause jitteriness and crashes, modafinil works by increasing dopamine and histamine levels in the brain, creating a heightened state of wakefulness without excessive stimulation. However, concerns remain about its long-term effects, with some studies suggesting that prolonged use could lead to dependence or changes in brain chemistry. Another well-known nootropic is alpha-GPC, a choline supplement that boosts acetylcholine levels in the brain. Acetylcholine is essential for memory formation and cognitive function, and alpha-GPC has been shown to enhance learning and recall. Athletes also use it to improve muscle contractions, but its most promising benefits lie in its ability to protect against cognitive decline. Some studies suggest that alpha-GPC could even help delay the onset of neurodegenerative diseases such as Alzheimer's. Lion's mane mushroom is a natural nootropic that has gained attention for its potential to stimulate nerve growth factor, NGF, a protein that promotes the growth and repair of neurons. Research indicates that lion's mane can improve memory, reduce anxiety, and even support neuroplasticity. Unlike synthetic nootropics, lion's mane appears to have long-term benefits, gradually improving cognitive function over time rather than providing an immediate boost. The rise of nootropics has led to a booming industry, with countless supplements marketed as brain boosters. However, not all of them are backed by science. While some compounds have legitimate cognitive enhancing effects, others rely on placebo effects or misleading claims. The key to effective brain hacking through nootropics is understanding which substances work, how they interact with neurotransmitters, and whether they provide temporary benefits or long-term cognitive improvements. Brain-computer interfaces, the future of human intelligence. The next frontier in brain hacking goes beyond supplements and enters the realm of direct brain-computer interfaces, BCIs. Elon Musk's Neuralink project has brought BCIs into the mainstream discussion, promising a future where humans can connect their brains directly to artificial intelligence. But what does this mean for human intelligence, and is it possible to enhance cognition through direct neural integration? Neuralink's goal is to develop implantable chips that allow the brain to communicate with digital devices. This could revolutionize everything from medical treatments to learning capabilities. For individuals with paralysis or neurological disorders, BCIs offer the possibility of restoring lost functions, allowing people to control computers, prosthetic limbs, or even entire systems with their thoughts. But the implications go far beyond medical applications. If a brain chip could directly interface with the internet, the ability to process information would no longer be limited by biological constraints. Imagine being able to download a new language into your brain in seconds or access real-time knowledge without needing to look at a screen. The concept is similar to how external hard drives store vast amounts of information, except in this case, the storage and processing power would be seamlessly integrated into human cognition. The ethical implications of BCIs are significant. If such technology becomes widely available, will it create a cognitive divide between those who can afford enhancements and those who cannot? Will privacy concerns arise if thoughts can be accessed or manipulated by external systems? While Neuralink is still in its early stages, its potential to transform human intelligence is undeniable. Whether this technology will be used to augment natural cognitive abilities or create an entirely new form of human-machine intelligence remains to be seen. Electrostimulation, hacking the brain with electrical current, one of the more controversial but increasingly studied methods of brain hacking is the use of transcranial direct current stimulation, TDCS. This non-invasive technique involves applying a weak electrical current to specific areas of the brain to enhance cognitive function. The idea is based on the principle that electrical signals drive all brain activity, so small external currents could potentially optimize neural processing. Research on TDCS has shown promising results in improving memory, learning speed, and problem-solving abilities. Military organizations, including the U.S. Defense Advanced Research Projects Agency, DARPA, have explored using TDCS to enhance soldier performance. In one study, participants who received TDCS while performing complex learning tasks demonstrated significantly faster skill acquisition compared to those who did not. One of the most well-known TDCS experiments involved using electrical stimulation on the dorsolateral prefrontal cortex, a brain region responsible for executive function and decision-making. The results showed that participants could improve their ability to solve difficult problems, think more creatively, and process information more efficiently. The technique has also been explored as a treatment for depression, as stimulating certain brain areas appears to enhance mood and cognitive flexibility. Despite its potential, TDCS is still an area of active debate. Some scientists argue that while short-term improvements are noticeable, long-term effects remain unclear. There is also concern that improper use of electrical stimulation could disrupt natural brain activity, leading to unintended consequences. Even so, TDCS represents a fascinating step toward direct brain enhancement, proving that cognitive function can be modified through targeted neural stimulation. Virtual reality and brain training, the new frontier of cognitive enhancement. Virtual reality, VR, has typically been associated with gaming and entertainment, but recent research suggests that it may be a powerful tool for brain training and cognitive enhancement. VR creates immersive environments that can stimulate the brain in ways that traditional learning methods cannot. The key advantage of VR is its ability to engage multiple sensory modalities simultaneously, reinforcing neural connections more effectively than passive learning. One area where VR has shown incredible promise is in memory training. Studies have found that navigating through virtual environments stimulates the hippocampus, the brain region responsible for spatial memory and navigation. This is similar to the effect observed in London taxi drivers, whose extensive route memorization led to physical growth in their hippocampus. VR-based memory training programs are now being used to help individuals improve recall, learn languages faster, and even rehabilitate cognitive function after brain injuries. Neuroscientists have also been exploring the potential of VR in treating conditions such as anxiety and PTSD. By exposing individuals to controlled virtual scenarios, they can gradually desensitize themselves to stressor and rewire their brain's response to fear and trauma. This approach, known as exposure therapy, has been successfully applied to veterans with PTSD, showing that virtual environments can actively reshape emotional processing pathways in the brain. Beyond therapy, VR is being used to improve focus and learning speed. A study conducted at Stanford University found that students who engaged in immersive VR learning environments retained information more effectively than those who learned through traditional textbooks or videos. The study suggests that the brain encodes information more efficiently when it is experienced in a three-dimensional space, reinforcing the idea that engagement and interaction are key to neuroplasticity. The combination of VR and artificial intelligence is taking brain training to an entirely new level. Eye-driven VR programs can adapt in real time to an individual's cognitive performance, adjusting difficulty levels and providing personalized training regimens. This level of customization allows for targeted cognitive enhancement, focusing on specific weaknesses and optimizing brain function more efficiently than ever before. As VR technology continues to evolve, it is likely to become a mainstream tool for cognitive training. Schools, workplaces, and even medical facilities are beginning to integrate VR-based programs to enhance learning, improve problem-solving abilities, and optimize mental resilience. Brain hacking through technology is no longer a concept confined to science fiction. Smart drugs, brain-computer interfaces, electrical stimulation, and virtual reality are already being used to enhance human cognition. While the ethical and long-term implications of these technologies are still being debated, the potential is undeniable. Whether through pharmaceuticals, electrical currents, or immersive digital experiences, technology is changing the way we understand and optimize the human brain. The future of cognitive enhancement is already here. The only question is how far we are willing to take it. The dark side of brain hacking: cognitive enhancement versus addiction. The promise of brain hacking is enticing: faster thinking, sharper memory, and enhanced creativity. But with every cognitive upgrade comes a potential downside. The rise of smart drugs and brain-enhancing supplements has created an industry worth billions, but it has also raised concerns about dependency, addiction, and long-term neurological effects. Many nootropics and pharmaceuticals, such as modafinil and Adderall, were originally developed to treat medical conditions like narcolepsy and ADHD. However, they have become widely used by students, professionals, and entrepreneurs looking for an edge in competitive environments. While these substances can temporarily improve focus and energy, prolonged use can lead to negative consequences. Studies have shown that consistent reliance on stimulants can alter dopamine levels in the brain, leading to dependence and withdrawal symptoms when discontinued. One of the biggest dangers of smart drug addiction is the tolerance effect. Over time, the brain adapts to synthetic stimulation, requiring higher doses to achieve the same level of cognitive enhancement. This cycle can lead to overstimulation, burnout, and, in extreme cases, neurological damage. Some researchers warn that continuous use of cognitive enhancers could disrupt the brain's natural balance of neurotransmitters, making it difficult for users to function normally without them. There is also the psychological risk of believing that natural cognitive performance is insufficient. People who use smart drugs regularly may begin to feel that they cannot function at their best without external enhancement. This mindset creates a dependency that is not just chemical, but also mental, reinforcing the idea that baseline intelligence is never enough. The long-term consequences of this dependence are still largely unknown, but experts warn that artificial brain enhancement may come with the Silicon Valley brain race. The pursuit of intelligence enhancement is no longer just a personal endeavor. It has become an industry fueled by billionaires, tech moguls, and private research labs. In Silicon Valley, where competition is fierce, cognitive optimization has become a key focus for entrepreneurs seeking to push human potential beyond its natural limits. Investors are pouring millions into brain enhancement startups, from companies developing AI-powered cognitive training to those working on neurochemical enhancements. Tech executives, including those behind major corporations like Google and Tesla, have expressed interest in brain augmentation. Elon Musk's Neuralink is one of the most ambitious projects in this space, aiming to integrate artificial intelligence with the human brain. Musk has stated that in order to keep up with the rapid advancements in AI, humans will need to enhance their cognitive abilities through direct neural interfaces. The concept of merging human intelligence with machines is no longer just theoretical, it is actively being developed. Other companies are exploring ways to enhance mental performance through brainwave monitoring, neurofeedback, and even genetic modifications. Startups are experimenting with technology that tracks brain activity in real time, using data to optimize focus and efficiency. Wearable neurotech devices, such as headbands that stimulate specific brain regions, are already on the market, promising to improve meditation, productivity, and learning speed. But the brain race is not without controversy. Critics argue that cognitive enhancement technologies could create a new class divide, where only the wealthy have access to intelligence-boosting tools. If brain-enhancing devices and drugs become mainstream, will those who can afford them gain an unfair advantage? The idea of cognitive inequality raises ethical questions about whether intelligence should be artificially enhanced and, if so, who gets to benefit. Case study: the DARPA Super Soldier experiment. The pursuit of brain hacking is not limited to the corporate world. The U.S. military, particularly through the Defense Advanced Research Projects Agency, DARPA, has been exploring ways to enhance soldiers' cognitive and physical abilities for years. Dubbed the Super Soldier program, these experiments aim to improve reaction time, focus, and resilience in combat situations. One of DARPA's most well-known projects involves the use of brain stimulation to enhance learning speed. Research has shown that applying electrical stimulation to specific brain regions can accelerate the acquisition of new skills. In a series of experiments, soldiers undergoing transcranial direct current stimulation, TDCS, while training showed a 50% increase in learning speed compared to those who did not receive stimulation. This finding has enormous implications for military training, where rapid skill acquisition can mean the difference between success and failure. In addition to electrical stimulation, the military has explored the use of pharmaceutical enhancements. Stimulants like modafinil and amphetamines have been used to keep soldiers alert during long missions, while experimental drugs designed to boost memory and decision-making are being tested in classified programs. Beyond cognitive enhancement, DARPA has also investigated ways to modify the brain's response to fear and pain. Some research suggests that altering the brain's amygdala, the region responsible for processing fear, could make soldiers less susceptible to stress and anxiety in high-pressure situations. While this could be advantageous in combat, the psychological effects of suppressing fear responses raise ethical concerns. Would a soldier who no longer experiences fear become more aggressive or reckless? The development of super soldier technology brings up another unsettling question: what happens when these cognitive enhancements are no longer limited to the military? If advanced neurohacking techniques become accessible to the general public, how will they be regulated? And more importantly, what are the risks of pushing the human brain beyond its natural limits? The risk of hacking gone wrong. Brain hacking has its potential, but what happens when it goes too far? Overstimulation of the brain, whether through excessive use of nootropics, prolonged exposure to electrical stimulation, or over-reliance on brain-enhancing technology, can have unintended consequences. One of the biggest risks is cognitive overload. The human brain is not designed to operate at maximum speed indefinitely. Just as a computer can overheat when pushed beyond its capacity, the brain can experience burnout when subjected to excessive stimulation. Individuals who overuse smart drugs often report mental fatigue, loss of focus, and an inability to concentrate without external stimulation. Sleep disruption is another major risk. Many cognitive enhancers, particularly stimulants, interfere with the brain's natural sleep cycles. Since deep sleep is critical for memory consolidation and brain repair, prolonged sleep deprivation can lead to cognitive decline rather than enhancement. Some individuals who experiment with brain hacking techniques report symptoms of insomnia, anxiety, and even hallucinations, indicating that excessive interference with brain function can have severe consequences. Perhaps the most concerning risk is the potential for unintended changes in personality and behavior. Some studies suggest that altering neurotransmitter levels artificially can lead to shifts in mood, increased impulsivity, or even changes in moral decision-making. If brain hacking becomes more advanced, will people begin to modify their personalities to fit certain social or professional expectations? The implications of such changes could be profound, raising questions about personal identity and the ethics of altering human nature. The ethical debate: should cognitive enhancement be regulated? As brain hacking technology advances, ethical concerns are becoming more pressing. Should there be limits on how far humans can go in enhancing their cognitive abilities? Should governments regulate the use of smart drugs, neural implants, and brain stimulation devices? One of the biggest ethical concerns is accessibility. If cognitive enhancement becomes a widespread practice, will it only be available to the wealthy, creating a new form of intelligence inequality? If brain implants or neural upgrades become a reality, will those who cannot afford them be left behind in an intelligence race? There is also the issue of consent. If cognitive enhancement technologies are introduced in schools or workplaces, will individuals feel pressure to use them to keep up? In high-performance environments, such as finance or technology, employees may be expected to use brain-enhancing drugs or devices just to remain competitive. This raises concerns about autonomy and whether individuals should be forced to modify their brains to meet societal expectations. Beyond individual concerns, there is the larger question of what enhanced intelligence means for society. If brain hacking reaches a level where people can dramatically increase their IQ, memory, and cognitive abilities, how will this reshape human civilization? Will it lead to unprecedented advancements in science and technology, or will it create a class of cognitive elites who dominate decision-making? The debate over brain hacking is far from over. While the benefits of cognitive enhancement are clear, the risks and ethical dilemmas are equally significant. As neuroscience continues to push the boundaries of what is possible, humanity will have to decide how far it is willing to go in the pursuit of intelligence augmentation. The future of brain hacking is not just about technology, it's about the choices we make as a society and the kind of world we want to create. Can brain hacking make you superhuman? Memory and speed reading hacks. The idea of achieving superhuman mental abilities has fascinated humanity for centuries. From ancient memory techniques to modern biohacking, people have always searched for ways to push the boundaries of their cognitive abilities. But can brain hacking actually make someone superhuman? The answer lies in understanding how memory, speed reading, and other cognitive skills can be optimized through deliberate training. World memory champions have demonstrated that the human brain is capable of extraordinary feats. These individuals can memorize long strings of numbers, entire decks of shuffled cards, and detailed historical facts in a matter of minutes. The secret behind their abilities is not natural talent but the application of specific memory techniques that leverage the brain's ability to recognize patterns and build associations. One of the most powerful memory techniques is the method of loci, also known as the memory palace technique. This method involves associating pieces of information with specific locations in a familiar environment, such as a house or a path through a city. By mentally walking through these locations, memory champions can recall vast amounts of information with incredible accuracy. Studies have shown that this technique dramatically improves retention because it engages multiple areas of the brain, including spatial memory and visualization. Speed reading is another skill that, when mastered, can significantly enhance cognitive performance. Traditional reading relies on subvocalization, where the reader mentally hears each word as they read. However, speed readers train their brains to bypass this limitation by processing multiple words or entire phrases at once. Techniques such as peripheral vision training and eye movement optimization allow speed readers to consume and comprehend large volumes of text at an accelerated pace. Some speed readers claim to reach reading speeds of over 1,000 words per minute, a skill that can dramatically enhance learning and information retention. The key to both memory and speed reading enhancement lies in neuroplasticity. The brain is not fixed in its abilities, it can be trained to process and recall information more efficiently. The question then becomes, how far can this training go? Is there a limit to what the human brain can achieve? Case study, the story of Daniel Tammet. Daniel Tammet is often considered one of the most extraordinary individuals when it comes to cognitive abilities. Diagnosed with high-functioning autism, Tammet possesses an astonishing ability to memorize and process mathematical information at a level that seems almost superhuman. One of his most famous feats was reciting pi to 22,514 digits from memory, a task that took over 5 hours to complete without a single mistake. What makes Tammet's case unique is that he does not rely on traditional memory techniques. Instead, he experiences numbers in a deeply visual and sensory way, seeing them as shapes, colors, and textures. This condition, known as synesthesia, allows him to form strong associations between numerical patterns, making it easier for him to recall them with extreme precision. Beyond his mathematical abilities, Tammet has also demonstrated remarkable language learning skills. In a widely publicized experiment, he was challenged to learn Icelandic, one of the world's most difficult languages, in just 1 week. By the end of the challenge, he was able to hold a fluent conversation in Icelandic, stunning linguistic experts. Tammet's abilities raise the question of whether such feats can be replicated through neurohacking. While he may have unique neurological wiring that enables his extraordinary skills, his case suggests that the brain is far more adaptable than most people realize. If certain cognitive processes can be strengthened through targeted training, could anyone develop similar abilities? The brain of savants versus neurohackers. Savants like Daniel Tammet have long been studied for their exceptional cognitive abilities, but they are not the only ones who possess seemingly superhuman mental skills. Many savants have extraordinary memory, calculation abilities, or artistic talents, despite having developmental conditions that affect other areas of cognition. Some can recall entire books word for word or perform complex mathematical calculations in their heads faster than a calculator. The main difference between savants and neurohackers lies in how their abilities are acquired. Savants often display their skills naturally from an early age, while neurohackers attempt to develop similar capabilities through training, technology, or biohacking techniques. The key question is whether the abilities of savants can be replicated by people without these unique neurological conditions. There is strong evidence that certain savant-like abilities can be trained. Studies on memory champions and speed readers show that with enough practice, the brain can be rewired to process information more efficiently. Musicians and artists who undergo extensive training often develop skills that seem almost superhuman to those who have never practiced them. Even chess grandmasters, who can play multiple games simultaneously without looking at the board, have trained their brains to recognize patterns at an advanced level. One experiment sought to determine whether ordinary individuals could acquire savant-like abilities through brain stimulation. Researchers applied transcranial direct current stimulation, TDCS, to the brains of participants while they engaged in complex problem-solving tasks. The results showed that those who received stimulation performed significantly better, suggesting that certain cognitive functions can be enhanced artificially. However, there are limits to how much training can replicate savant abilities. Many savants possess innate brain structures that differ from the average person, allowing them to process information in unique ways. While neurohacking can certainly improve memory, learning speed, and problem-solving, it is unclear whether it can fully replicate the abilities of natural-born savants. Does brain hacking have limits? The concept of brain hacking suggests that human intelligence and cognitive abilities can be enhanced indefinitely. But is there a point where the brain reaches its natural limits? Science suggests that while the brain is highly adaptable, there are constraints to how much it can be optimized. One of the primary limitations of brain hacking is the brain's energy consumption. The human brain already uses about 20% of the body's total energy, making it the most energy-intensive organ. If cognitive abilities were dramatically enhanced, the brain would require even more energy, potentially leading to increased fatigue or other metabolic imbalances. This is one reason why extreme cognitive exertion, such as long hours of deep concentration, often leads to mental exhaustion. Another limitation is information processing speed. While memory techniques and speed reading can improve recall and comprehension, the brain still has a limit on how quickly it can process and integrate new information. Attempting to learn too much at once can result in cognitive overload, where the brain struggles to retain or apply the knowledge effectively. There is also the issue of emotional regulation. Enhancing cognitive abilities does not necessarily mean improving emotional intelligence. Some of the most intellectually gifted individuals struggle with emotional processing, suggesting that different aspects of cognition operate independently. If brain hacking focuses solely on intelligence and memory, it may come at the expense of other important mental functions, such as empathy and intuition. Ethical concerns also play a role in determining the limits of brain hacking. If cognitive enhancement technologies become widely available, should there be regulations on their use? Should there be a limit to how much intelligence can be artificially boosted? These questions will become increasingly relevant as brain hacking techniques continue to evolve. While the brain is capable of extraordinary feats, true superhuman intelligence may still be beyond reach. However, the techniques used by memory champions, speed readers, and neurohackers prove that the human mind is far more flexible and capable than previously thought. With the right training, anyone can push their cognitive abilities beyond what they once believed possible. The real question is not whether brain hacking can make someone superhuman, but rather how far we are willing to push the boundaries of human potential. The future of brain hacking. Will we merge with AI? The fusion of human intelligence with artificial intelligence is no longer a distant fantasy. Advances in brain-computer interfaces, BCIs, suggest that the next stage of cognitive evolution may involve direct integration between the brain and AI-driven systems. Neural implants, once confined to medical applications like restoring movement to paralyzed individuals, are now being explored as tools for cognitive enhancement. Elon Musk's Neuralink has already demonstrated the potential of brain implants, showing that neural interfaces could allow direct communication between the mind and machines. If perfected, such technology could enable individuals to process and retrieve information instantly, bypassing traditional learning methods altogether. Imagine being able to upload knowledge to your brain the same way a computer downloads software updates. While this concept still raises ethical and safety concerns, researchers are moving closer to making it a reality. AI-powered brain augmentation could also eliminate cognitive limitations caused by aging or neurological disorders. Future generations may have the option to enhance their intelligence artificially, making forgetfulness, slow learning, and mental fatigue problems of the past. However, the implications of merging human cognition with AI raise fundamental questions about identity, free will, and what it means to be human. The singularity and enhanced human. The idea of the singularity, a point where artificial intelligence surpasses human intelligence, has been debated for decades. Some scientists predict that once AI becomes advanced enough, it will drive rapid self-improvement cycles, leading to superintelligence beyond human comprehension. If humans do not enhance their own intelligence through brain hacking, they may be left behind in a world dominated by AI-driven decision-making. The emergence of enhanced humans, those who use brain implants, nootropics, and neuro-AI integrations to boost cognitive function, could create a new class of individuals with abilities far beyond those of the average person. These enhancements might include hyperintelligence, perfect memory, and even the ability to process vast amounts of data in real time. Some experts argue that this could lead to a cognitive divide, where enhanced individuals dominate scientific discovery, business, and leadership, while others struggle to compete. But will these enhancements create an entirely new species of super-intelligent humans, or will they simply expand the natural capabilities of the brain? The answer remains uncertain. What is clear is that the future of cognitive enhancement will not be limited to natural training techniques. The human brain is on the verge of a transformation that could redefine intelligence, productivity, and even consciousness itself. What this means for you. While brain-computer interfaces and AI integration are still developing, there are already ways for anyone to start optimizing their brain today. The fundamentals of brain hacking remain accessible to everyone. Improving diet, practicing meditation, using memory techniques, and leveraging technology to enhance learning. Understanding neuroplasticity allows individuals to take control of their mental growth, whether through natural or technological methods. Enhancing intelligence and memory does not require a futuristic brain implant. Simple, science-backed habits, when practiced consistently, can improve focus, recall, and cognitive performance. While the future may bring radical new methods of brain hacking, the most effective techniques today remain rooted in understanding how the brain works and taking advantage of its ability to adapt. The brain is the most powerful tool we own, and we are only beginning to understand how to optimize it. As science unlocks more secrets of cognitive function, the potential for brain enhancement will continue to expand. Whether through natural techniques or cutting-edge technology, human intelligence is evolving, and those who embrace brain hacking today may be best prepared for the world of tomorrow. If you could rewire your brain to master any skill instantly, what would it be? Let us know in the comments.